Hello, everyone, and thank you so much for joining us today. My name is Kirk Lane. I'm a senior sales engineer here at PhoenixNAP, and I'm excited to talk to you today about keeping safe from ransomware with protection and recovery best practices. This is the second installment in our three-part webinar series. Be sure to join us again to discuss replication and disaster recovery comparisons on Thursday, March 8th. Today, we're going to discuss the risk vectors presented by ransomware today, best practices for securing and protecting your environment, and current data protection and recovery solutions. We'll introduce you to Zerto and how you can use their software to recover from a ransomware attack in just minutes with minimal impact. Before we begin, I'd like to tell you a little bit about PhoenixNAP. PhoenixNAP is a full-service infrastructure-as-a-service company that was founded in 2009. We are headquartered in Phoenix, Arizona, and Amsterdam, with physical locations in multiple countries globally. We've been a proud Zerto Cloud Services provider since 2015, and are also a Nimble Elite Service Provider and VMware Premier Service Provider. PhoenixNAP offers global connectivity with data center locations in Phoenix, Arizona, Ashburn, Virginia, Haarlem in the Netherlands, Atlanta, Georgia, Los Angeles, Belgrade, Serbia, and Singapore. We have new locations opening soon in Seattle and Chicago. We offer a global WAN network of over 1 terabit per second capacity and layer 2 connectivity between all locations. Intercloud connectivity is available through PhoenixNAP with AWS, Azure, and Google as well. PhoenixNAP offers a full-service data center experience with a wide variety of infrastructure-as-a-service offerings. These include solutions such as traditional colocation, managed private cloud, virtual private data center, public, and hybrid cloud solutions. We also offer a wide variety of bare metal servers, S3 compatible object storage, hardware as a service, and backup and recovery service options. And today's topic is ransomware and the facts you should know. We'll begin by taking a quick look at some ransomware facts. In the first quarter of 2016 alone, it's estimated that more than $209 million were spent paying ransoms for critical data. This does not include the cost of downtime incurred as well. It's estimated that CryptoWall 3.0 alone made over $325 million from US victims in 2015. These numbers are still climbing exponentially. Single incidents can bring in millions of dollars each, with some companies disclosing having paid more than $2.4 million per incident in ransoms and recovery. The rate of attacks is rising exponentially as well. 2015 saw 3.8 million attempted attacks, with that number skyrocketing to 638 million in 2016. That's more than 167 times the number of attacks seen in 2015. This increase is largely attributed to the ease with which cyber criminals can make huge sums of money by holding critical data hostage. The current form of ransomware was first reported in May of 2013, but the concept isn't new. Advancements in encryption and ease of anonymity have made it a viable money-making strategy. Some of these advancements include the offering of Ransomware-as-a-Service, making it easy for even inexperienced cyber criminals to expand the use of these Trojans as well. By September of 2016, it was estimated that at least 1 in every 5 companies had experienced some kind of ransomware attack. The varieties of attacks increased in 2016 as well. At the beginning of the year, 2,900 varieties of ransomware were known. By the end of the third quarter, that number increased to over 32,000 varieties, with 62 new ransomware families appearing that year alone. These families include ransomware such as CryptoLocker, CTB Locker, CryptoWall, Locky, and many more. There are many variants with subtle differences, but all aim to do essentially the same thing: encrypt files and demand a ransom. Some families such as CryptoLocker no longer exist thanks to law enforcement, but more variants are created daily. With so many varieties of ransomware out there, it's no surprise that more than 1.7 million attacks are attempted globally each day. Small to medium businesses are the least likely to have proper protections in place, and so are often the hardest hit, with research showing as many as 42% falling victim to some sort of ransomware attack each year. Of course, merely paying the ransom doesn't mean you'll get your critical data back. In 2016, Out of the 1 in 3 affected companies that paid ransoms to get their data back, 1 in 5 was still unable to recover their files. Overall, 67% of companies affected by ransomware that year lost part or all of their data, and 1 in 4 victims spent several weeks trying to restore their access, a costly endeavor. Ransomware attacks have become so commonplace that they are increasingly talked about in mainstream media. From BBC to NPR to shows like Grey's Anatomy and NCIS, including ransomware in their plotlines, it can be hard to ignore the presence of these attacks in the news and in day-to-day life. Business users are increasingly seen as a primary priority target, as these organizations are considered more likely to pay the ransom and to pay more. Organizations with public-facing services, particularly those in local government and healthcare, are often favored targets. In February of 2016, Hollywood Presbyterian Medical Centre experienced a ransomware attack that lasted 10 days. This attack affected multiple departments. Staff had to switch to pen and paper record keeping, and the hospital lost over $1 million each day in revenue just from their CT scanners being down. The hospital eventually paid $17,000 via Bitcoin in ransom. Radiation tracking at Chernobyl, oil production, aircraft manufacturer, pharmaceutical companies, municipal services, and more have all been affected in the past by ransomware. With Ransomware-as-a-Service becoming more prevalent, attacks continue to rise. One thing is for sure, the threat is big enough to consistently make international news. There were over 750,000 attacks in 2015 alone worldwide. It's critical to look at ransomware as a global problem. Most attacks are directed at companies in more affluent countries. This makes a lot of sense. Companies in these areas tend to be more likely to pay a ransom and typically can pay a higher amount. While private users are once a main target of ransomware, today the attacks are increasingly focused on businesses. Because of this, the threat of ransomware is now continually at the forefront of most business leaders' minds. It's no longer if, but when an attack will happen. And when it does, how will you recover? When we stop to analyze this, we need to look at not only recovering from such a virus, but also protecting all the other endpoints in our networks. Any vulnerability can cause a huge problem, so ideally we don't want this in our network at all. Let's talk about what a ransomware attack really is. Ransomware Trojans will search all accessible files and network file shares. Some will even directly target backup files if they're accessible. The ransomware targets file extensions and will encrypt the files. Once this has happened, the results are often the same. You can either pay a ransom to recover your data or recover from another method. The impact is staggering. With access to critical data blocked temporarily, or worse, unrecoverable, this leaves many victims with very little choice. Ransoms are generally paid in cryptocurrencies to add an additional level of protection for the hacker and trouble for the victim. These types of funds are generally untraceable and unrecoverable after they've been paid. Because of this, attacks are becoming more frequent. Hackers are making large amounts of money with very little risk, while targeting data-reliant companies who really have little other choice if they were not prepared to recover from such an attack. It's a perfect crime. Ransomware attacks are less traceable than credit card fraud, easily deployed, and paid out quickly. So how does this all happen? It starts with something as simple as a phishing scam or exploit kit. In this example, we will use CryptoWall 4, which is prevalent around the end of 2015. Once the victim has been compromised by a phishing scam, the binary is downloaded and executed. This could be a zip file and a script, an affected Word document with a macro, any means to deploy the payload. In this case, the binary is injected into explorer.exe. The ransomware's activities are meant to achieve persistence and hide its tracks. The ransomware makes itself persistent by using a registry key. Any user should remember that if persistence is successful, the encryption function will run again on the next reboot to encrypt any files the user created after the initial infection. CryptoWall sets about these to copy itself to the app data directory, creating a registry entry that enables it to start up at each boot, terminating the primary malware process and deleting the original file. It then injects itself into service host. Injection into this process gains it the privileged level of access to the machine, which allows the deletion of all available shadow copies without the user being prompted for a user account control dialog to approve the deletion. It then downloads the RSA public encryption key from its control and command server, which allows CryptoWall to encrypt the files and block access to them from the user. The ransomware then encrypts the file name along with the data. The RSA key is used to encrypt the AES encryption key, which is later encrypted with a download public key and embedded in the encrypted files. The user's device then displays the ransomware to the user in three formats: PNG, text, and HTML, to ensure the user knows what has happened and what the attacker's demands are. The only way to recover from this attack is to have access to the private key, which is used to encrypt the public key. The private key can then be used to decrypt the key to restore data to functionality. In this example, CryptoWall 4 is actually smart enough to exclude certain file extensions and directories to ensure that the operating system still works and the user can still use that terminal to pay the ransom. The bad news is that CryptoWall 4 shows no signs of becoming weak. Like most ransomware, it uses very strong encryption. While attacks like these are becoming more intelligent, the program is not perfect and does have flaws which can be exploited. Many security companies are publishing white papers on the details of current ransomware attacks. By walking users through how they work and giving suggestions on ways critical data can be protected, some light is being shed on the situation and companies are able to better protect themselves. For example, if a strong firewall or IPS can block the packets, an infection can be prevented. One very good example of this includes a company that identified the crypto server sending encrypted packets to get the encryption keys. These packets can be blocked, causing the malware to not be able to get the keys, which forces it into a loop. While this sounds simple enough, the reality is the list of target servers is constantly changing and encrypted within the code itself. If you're able to quickly remove a PC from the network during the installation phase, you may be able to save your data, but few are ever that lucky. At the end of the day, the best strategy against ransomware attacks is a strong recovery strategy. Stopping or reducing infections is often possible with a few key steps. First, it's important to understand your ransomware entry points. These can include web attachments, downloads, USB drives, and personal devices. It's as simple as a user accidentally downloading a file that turns out to be executable. Naturally, with so many entry points, this risk is not limited to just IT staff. Internal and external users, contractors, or anyone who has access to the network can be a potential vector. Unfortunately, once a virus like this gets access to the network, it has a potential to infect databases, disks, map network shares, or anything else it can reach. It's a good idea to make sure entry points are secured. Filter web traffic and block malicious sites proactively. This can include blocking users from certain IPs that shouldn't have access. It's also important to scan email attachments to reduce the amount of phishing attacks and malware ever sent to users. USB devices should be scanned or even potentially restricted on the network, and any personal devices should be locked down or secured to separate networks away from production environments. Blocking web access on virtual machines can also help preventing shortcuts that can prove to be insecure. Users themselves are also another huge point of entry, so it's vital that all users on the network are regularly trained in what to look for in a ransomware attack. This allows them to recognize potentially risky activities before partaking in them on the network inadvertently. Installing antivirus protection and keeping that software updated is also incredibly important. Users are prone to mistakes, unfortunately, so that extra layer of protection helps to assure that mistakes are less likely to be made. Additionally, intelligent administration of your network can make all the difference. Implementing change control and isolating external users can reduce risk significantly with very little work. By not giving users access to permissions they do not absolutely need, you reduce risk to the environment. Domain administration access should be restricted as well. CryptoLocker viruses will infect anything on that machine which the user has access to. In a large Active Directory environment, reducing the number of users with admin permissions can reduce the risk of ransomware taking hold. Users who have that level of permission should be prevented from browsing, emailing, and performing other non-vital tasks while logged in with those permissions. Implementing group policies for departments that prevent non-required users from running exe files and the like is always wise as well. The storage and network itself can also present a risk depending on how it is set up. Audit file share permissions regularly and remove anything non-vital. Ransomware exploits connectivity to render the most damage, so reducing that will reduce risk. Using read-only permissions where practical can reduce the amount of data an infection can penetrate, should one occur as well. Set up firewall policies carefully to block any ports not in use, and use VLANs to help segregate user environments from production and limit the impact of an attack as well. Good practices may also involve setting up a honeypot in your network to capture and alert any suspicious activity. This helps mitigate attacks early on before they manage to completely take hold. Unfortunately, despite proactive measures, ransomware attacks can still happen. Day zero attacks still pose a risk when the infection or virus is not known to security companies. Ransomware is constantly evolving. Hackers are evasive and clever and find new weak points all the time, and must continue to do so in order for ransomware to yield rewards for them. Despite many different strategies and best practices being employed, it's only a matter of time before new weaknesses are found and exploited. Securing your infrastructure using current best practices and isolating your test network can go a long way. Protect your data, plan to respond, and have a planned and tested process to restore your data. Paying a ransom should not be an option. Some victims have paid the ransom and received no keys. Others have paid once, then been forced to pay again. The best thing you can do is plan ahead in order to keep yourself from being a victim. In the case of an attack, it is vital that companies be prepared to respond, communicate, and find the source of the infection. These are vital lessons learned that can help companies locate weak points and isolate them while taking steps to prevent future attacks. Once you have responded to the threat, you will need to restore the data. Test your restoration process regularly and restore your data. From there, it is vital to perform a root cause analysis to prevent future attacks and update your security and recovery plan accordingly. When it comes to data protection solutions, there are different solutions for different needs and expectations. Nightly backups are still extremely common within business, and many of you are probably doing this today. Sometimes new technology comes out that is now affordable and allows you to take advantage of things like snapshots, taking a point-in-time picture of that environment or storage or virtual machine to help reduce your recovery point objective and reduce your recovery time objective as well. When you hear about new technologies that are tried and true in the industry, take some time to look into them because you don't want to be doing what you're doing just because it's what you've always done. You don't have to accept that. Remember, times are changing. The competition is driving new technologies, new methodologies, and more value than what you've experienced during your last business continuity disaster recovery activity that involved planning out your strategy. Quite often, businesses are implementing multiple strategies and solutions to accommodate different types of disasters, such as power or hardware failures, network outages, data corruption, or loss through deletion, or other things like ransomware, or just due to errors. These solutions bring different operations and can oftentimes their own RPO and RTO numbers that they can offer the business. But in any case, these impacts all cause data loss and downtime. So to minimize the impact, in an ideal situation, you'd be able to roll back very quickly with little to no loss and use the same solution to recover from multiple types of disasters. There are still times you'll need to use a certain solution for specific reasons, but the majority of use cases can take advantage of a solution or a cloud provider that can give you access to these capabilities for all of your disasters, including site failures, application failures across virtual machines, single virtual machine failures, and even failover recovery from any of those virtual machines. How we did this with Zerto was by revolutionizing the way replication is done. Before Zerto came along, if you needed to replicate the data for disaster recovery, there was only one way to do it at scale, and that was in the physical layer doing storage-based replication. And it was vendor locked in. You would need to have 2 matching storage arrays between sites, and you're only replicating the data itself. There's no automation, no orchestration, meaning you would have to either perform the failover manually or purchase another solution such as Site Recovery Manager. Zerto revolutionized replication by moving it up into the hypervisor and by including all the automation and orchestration in one solution. It can replace everything you're trying to do before, all in one simple to use solution that also removes the lock into the storage. This makes replication and recovery completely software-defined, and most importantly, again, simple. And if you look at the trend since Zerto Virtual Replication was first released in 2011, other technologies have followed the same path. Everything is moving towards hypervisor agnostic, software-defined solutions, such as VMware NSX, software-defined storage. Everything is targeting the ability to separate the technology from the hardware, allowing more flexibility in vendor selection and deployments. Because once you've standardized your environment on Zerto, it gives you resilience for your IT as it evolves, because first of all, you can change. Once you remove that vendor lock-in, you can be completely agnostic to the underlying storage and the underlying hypervisor. You can take on new technologies, like all flash arrays, for example, reuse hardware when some of it's refreshed, try a new storage or hypervisor vendor, anything. You gain protection across all VMs, storage, and hypervisors, and minimize that impact in just seconds. You can test the recovery for any of those systems and remove the risk by being able to prove you can recover and go back to any point in time. You gain the ability to recover in minutes to maximize uptime, and are also able to use the same software to consolidate multiple data centers and perform migrations, not just disaster recovery. Your environment can evolve and use Zerto to replicate to over 300 clouds, including Azure, Amazon Web Services, and PhoenixNAP clouds, so you can find the right provider to meet your business and industry needs as well. With all of these different use cases, you're actually going to simplify your IT and future-proof your environment because you now have a hybrid cloud solution that allows you to easily and quickly consume all these different services, hardware, storage, hypervisors, and clouds, all from a single solution. So how does this work? The first thing you need to do is install the Zerto Virtual Manager, or ZVM, that plugs into your vCenter or System Center, depending if you're running VMware vSphere or Microsoft Hyper-V. It's a simple .NET installer that gives you an easy-to-use management interface, along with the orchestration and automation capabilities. ZVM installs in minutes with no disruption or downtime. The data is replicated using the scale-out hypervisor-based Zerto Virtual Replication Appliance, or VRA. These are deployed from the Zerto Virtual Manager. They are very small in footprint and run on each of the actual physical hosts in your environment. This allows every protected VM to have a local replication appliance, no matter where it moves around to within the cluster. And it creates a scale-out architecture, meaning Zerto can protect your environment with the same software, whether you're a 10 VM environment on a single host or have thousands of VMs to protect in your environment. These appliances have built-in compression of the replication traffic and allow you to throttle it at different time periods throughout the day. And they also have resilience to WAN outages. So if a network link goes down, they don't just start storing a huge amount of data. They just keep an online index in memory of the most recently changed blocks of data, which then replicate once the network link comes back online. It automatically self-heals. The VRAs are only replicating the virtual machine block level changes. It is performing real-time, continuous replication, removing the need for any scheduling. If nothing is changing, nothing is replicating, and as soon as a block changes and is written, it is asynchronously tracked and sent to the recovery site with no snapshots and no impact. ZVR is constantly tracking these writes and the order in which they are written as to capture recovery checkpoints that maintain this write order fidelity of the data without having to snapshot, pause, or stun the VM. The recovery site contains virtual disks for the replica of the VM data and journals for the latest changes up to 30 days back. With compressed data, typical DR site storage space required is a space for the utilized VM base disk and an additional 7 to 10% of that space for the journal. Since we're talking about building your own clouds and providing your own solutions, let's switch gear a little bit and expand on the concept of disaster recovery as a service and what that offers to your business. Disaster recovery as a service means someone else is hosting your disaster recovery site. This might mean you have an on-premise cloud and want the DR to someone else's cloud, or it might mean you have already moved your workloads from off-site into the cloud to run, but want to have a disaster recovery site, another one of their cloud sites. When you run your own DR site, you have the expense of power, cooling, real estate, hardware, networking, administration, licenses, maintenance, and other expenses. Not only that, but you're locked in. You've logged into that site for a period of time, and moving from that site whenever you want to isn't particularly easy or quick. Refreshes cost a lot of money and of course grow exponentially if you maintain more than just one DR site. With disaster recovery as a service, you only pay for what you use, and you also have the flexibility to migrate there if you decide to in the future. You don't carry the cost or the planning of hardware refreshes on that site. You can predict almost exactly what it's going to cost you for the year, month to month, and you can even take advantage of managed cloud providers that do all the work for you. You can even let them manage the infrastructure and DR events as well. One key concept in Zerto is consistency grouping. We took the concept of placing all VMs in the same storage LUN in order to achieve data consistency between VMs and applied that across all storage in your environment. Typically, with storage-based replication, you would take all VMs that belong to your enterprise application and place them on the same LUN, snapshot that LUN, replicate it and recover the LUN, and all your VMs would be there from the same point in time. What if you want to mix and match storage or LUNs for your VMs, but still want to maintain consistency between them? What if you need to replicate to the cloud? You can't do that with traditional methods using storage replication. Zerto took the replication and moved it to the hypervisor so it's no longer dependent on storage itself. With our virtual protection groups, we protect all the VMs together that you add to the VPG, give them all granular checkpoints with right order fidelity across the VMs, and allow you to recover them together from the same point in time. It doesn't matter what storage or LUN they are on, replicate from anything to anything. When you create the protection group, you pre-configure all your settings, networks, security, sizing, prioritization, etc. So it's all ready to go when you need to failover. Another key thing with Zerto is removing the reliance on individuals. If you had a disaster today, how many people would you have to get together and how much would you have to orchestrate to get everything right no matter what time, day or night? Prior to using Zerto, no matter the size of your environment, you're calling on your most skilled employees in each area to help guide you through the process to ensure success. You have to hope the knowledgeable resources are still on board or have transitioned their tribal knowledge for the process. With Zerto, it's 4 simple steps. You click Failover. You select all of your applications or virtual protection groups. It could be just one, all, or a subset of them. You verify your recovery settings and decide if you want to recover from the most recent checkpoint or a validated checkpoint further back in the past. And then you click this Failover button and let Zerto do the rest. It's as simple as that. This is all your DR plan needs to contain in order to perform the failover itself. And you can also use the same journal and checkpoints for restoring a file or files as you use to restore a VM or a group of VMs or an entire site. Once you get your restoration request, just launch the wizard and select the VM you want to grab the files from. Look through your checkpoints, select the latest copy, or choose from all your previous point-in-time checkpoints. Select all the files or folders you would want to recover. This could be a single file, a folder, or a database. And then click the download button and the selections will download straight through to your workstation. Zerto is completely integrated with your hypervisor. And the key thing I want you to notice here is that you can see all of your protected VMs you can see across your VMs is that you are shown the real-time recovery point objective. You won't find another solution that's going to show you this, let alone right when you log into the dashboard. Zerto will give you that real-time RPO across your site and for each virtual protection group as well. It doesn't matter what your environment is underneath, you get the same interface every time. And you also use this information to perform and prove out your DR testing, with reports generated and all available right through this dashboard. From the Zerto Virtual Manager, you can run these detailed reports to prove that you can recover, how long the recovery took to perform, who did it, and what the outcome was. You can use this against multiple regulatory compliance standards, and you can also brand it with your own logo as well. Now that you understand more about how to keep your business safe from ransomware, I want to discuss a real-world customer example. In this example, the customer was infected by CTB Locker. Edit permissions were granted to the user to files that perhaps should not have been. Regular permissions audits might have prevented the consequences of this particular attack. However, even with regular audits, mistakes can happen. The customer isolated the affected PC from the network and utilized ZVR to recover files in mere minutes before the virus took hold. Since they were able to do this, no ransom needed to be paid, and the impact of the virus was minimized. Upon looking into things further, the customer found the user who caused the infection had been browsing the internet and was inadvertently infected. Retrospectively, firewall rules were updated to block IP addresses from countries that would not have been allowed otherwise. This customer was grateful to have Cerber replication available, as this was not the first time they had experienced this issue. In the previous instance, they had not been able to find the source and respond as effectively. To summarize, you would need enterprise-class software for disaster recovery that is hypervisor-based and fully virtual aware. You need the ability to protect to multiple clouds, including public, private, and hybrid clouds. You need a solution that is storage and hypervisor agnostic to allow you to minimize the impact of an outage and rewind an entire consistency group to the second in just minutes. And what Cerber provides is all of this as a powerful data protection and recovery solution that installs in minutes non-disruptively. And thank you again so much for your time today. We do have a third installment coming up on March 8th to go for the next event in the series. Anyone who attends all 3 webinars will be entered in for a chance to win a Kindle Paperwhite e-reader. I do see we have at least one question on the webinar here. I'm going to pull that up. Okay, it looks like the questions are based around determining what point in time you would need to roll back to. This is where the, specifically how you determine what point in time to roll back to, identifying so you don't replicate a point in time that was already where the CryptoLocker or similar virus had already performed its encryption of your data. A large part of that is going to be monitoring your network as a whole. Typically, an event like this is going to, once the encryption is actually taking place, it's going to have some very visible activity to go with it, whether it's a sudden spike in disk activity, lockdown access from files. And with Cerber, because you get that down to the minute or down to the second granularity, you should be able to quickly identify, from a known point in time, whenever the event was first noticed, you shouldn't have to go back very far before you're able to get to a time where you know that everything was still clean and in production. These viruses do tend to attack quickly. They don't. They generally don't stay around and wait for hours or days on end before they actually perform their work to lock down files. So usually, as soon as someone's noticed it, you can go back a matter of hours, minutes or hours from when that was noticed, and find a still clean replication to go from. You would still need to ensure that you've taken steps to lock down the environment after that. Identify whatever that entry point was and actually lock that off from a repeat infection. Okay, just seeing an update to that question here. As far as variants of ransomware that wait before they detonate, that would definitely be a more in-depth analysis of the environment required for that. If you've known you've been impacted by a version that waits to detonate, your best bet would be identifying where that process is, replicating, and taking actions to mitigate that before it detonates again in the replication environment. All right, if we don't have any other questions this time, I'm going to go ahead and wrap this up. Thank you again for your time today. Just one more reminder, just if you attend all 3 sessions, you'll be entered in for that drawing for the Kindle Paperwhite e-reader. Again, if you have any other questions, please feel free to reach out to us. We're available anytime.